Hello everyone and welcome to our educational presentation. My name is Paul Arsov and I'm the founder of the Decentralized Web project. The topic of this presentation today is risks in AI generating training data and the need of close supervision. We can remember that a while ago the US government announced a $700 million investment in the global goal of producing quality data for military intelligence program called MAVEN. The project sought to create so-called ground truth data sets that could be used to train AI to recognize friend versus foe designations across variables source of military intelligence using and including satellite and aircraft images. This money was earmarked for manual labeling for human labelers to encode what they believe the images contain, such as, for example, tank movements or other content of military importance. The significant dollar amount of this investment reinforces what we have long known. There's a huge amount of data available for training machine learning models. Modern ML is notoriously data hungry, and the lack of quality data has long been one of the inhibitors of rapid progress in the field. The investment in MAVEN reflects one of two approaches for dealing with resources constraint, that is generating new dataset. The other is to make the models more data efficient, like for example to do more with less. What has not been proposed or attempted is for agents to define their own ground truth datasets, like for example by labeling their own images, just as humans do when forced with this task. Only human researchers are permitted to collect their own data. Only they're permitted to clean it up, structure it correctly, and finally push it through some statistical computational pipeline. AI models cannot be trusted to sift through the images by themselves and compile their own ground truths. The later suggestion sounds both implausible and understandable. We humans consider ourselves the measure of all things, that is, the source of all foundational truth. Whenever a decision must be made as to what to include in a data set, we don't believe AI is fit to make the call, to select which samples are valid and filter out those that aren't, without at least some initial human guidance. The AI must infer conclusions based on that initial step, but we humans are the only ones permitted on the ground floor. At some point, the decision must always come back directly or indirectly to a human evaluation and a human judgment call. Anytime a doubt creeps into a model's performance, it is always left to a human to prepare the necessary corrective. This deductive process, of course, leaves the AI helpless outside of the data we give this AI. The models become fragile, always dependent on the human guidance and intervention. Any AI that did claim the authority to define its own data sets, like truths, could, by that fact alone, also plausibly claim to possess human rights in some sense. And that is a thorny and nuanced issue. So for the moment, we prefer to clone our own truth into AI as a form of employee training. As with any piece of software, our hope is to create authentic substitutes for our decision making that do what we want them to actually do. The need to create labeled data sets reflects the need to transmit our wisdom as a binary package into AI. Yet rarely we do pause and try to determine when that wisdom came from where and how it was created by us. This is no small omission. Whoever defines the data sets defines to a large degree the outcome, fact that is center stage in debates over data bias. Despite the common wisdom, numbers can lie, and statistics has given a bad rap, worse than demented lies due to the influence initial data decisions can have on the output. Which images do or don't count as suspicious enemy behavior must be made explicit in the data set, and those early designations determine the statistical correlations that will be subsequently discovered in the data. Why can't an AI make these decisions itself? What is preventing an agent from being the creator in its own datasets? Humans, admittedly, have access to a large universe of experiences than AI do. And we live in the real world. We have conversations and refer to events of which AI have no awareness. With this in mind, one viable option may be to move away from employing tailored supervised data sets to a more open reinforced learning agents. RL, in principle, may invite agents to collect their own data sets through unguided exploration in an open environment, although this possibly has yet to be seriously studied. The question on how an AI can determine its own ground truth revolves in the end to the question of how RL type agents can create discrete all or nothing information. Creating a ground truth is always an act of selection, filtering, and restructuring of raw real-world experiences, grouping together what is important, deleting what is noise. This transition from open exploration to structured, discrete truth is what is at question here. Um, is it entirely out of question for us to trust an AI to decide if an image were a friend or foe? Uh, Surely the data is there, merely waiting to be collected in some way. If we go by the assumption that the ground truth arises directly out of the data itself, then nothing but the data is important to the outcome. On this assumption, a data set, whether it includes every experience an agent has, as in the case of RL, or some curated subset of those, as in supervised or semi-supervised models, is fundamentally the same. Data is merely what is available to the agent via its inputs. All that is required for an agent to define its own data sets is a physical body and some data transformation function. Yet, is this true? It seems like there is more to a data set than merely a refinement of our total experiences. The selection process is not trivial. It's not just a question of dumping a data lake worth of information into a model and hoping it will supervise itself and create a data set. Were this the case, we would not be spending millions of dollars doing it manually and by human beings. A data set is ultimately an opinion, like friend or foe, one which could be made differently depending on who you ask and when you ask them. It is not impartial. There is a strong connection here between questions of moral alignment, such as between humans and AI, and the process of creating discrete data sets from a stream of empirical inputs. What is missing is a theoretical framework that defines the move from a raw stream of empirical data to the active selection of data sets. It is wrong to treat them as interchangeable, as though all the necessary information for determining the later was available for the former. And all that is needed is transformation function. They're separate, standalone entities created by humans, and that creative process influences the outcome. The experience of transformation one into the other could even teach us something important about the nature of human cognition. From the above, a few challenges have already revealed themselves when confronting this task. There are a number of questions like how does the AI becomes the arbiter of discrete knowledge or concepts. How can AI judge in case of ambiguity and contradiction in order to establish its truth? Then how can it create novel concepts and ideas? And finally, how does it reason about what it has experienced? And with this, we are ending this part one presentation. And with the next week, we are going to have part two of this presentation and the answers to these questions. And with this said, I'm coming back to the beginning of this presentation when I told you that my name is Paul Arsov. I'm the founder of the Decentralized Web project, and currently we are working in several different projects. The first project that I like to mention is a project of a marketplace and collection of non-fungible tokens. What is interesting, unique, and special about this project is that these NFTs are based on three-dimensional images. With three-dimensional images, there has to be some special software which loads, reads the 3D object file, then it opens a window on a computer screen. It displays the file that it reads of this 3D object, and then it can animate the 3D object in certain way. Traditionally, the creators of 3D objects, they were using some standard software for displaying of 3D objects, and currently there are two very popular choices which are game engines, and one of them is called Unity, the other one is called Unreal. But from the very beginning we decided to build our own 3D software engine, and what it does is it reads the file of the 3D object, it opens a window on a computer screen, it displays of the 3D object, and then it starts animating of this 3D object by way of moving it in a random fashion around the window it did open. But in addition to these basic capabilities for reading, opening a window, displaying and animating of 3D object, our 3D software engine has multiple additional capabilities. The first additional capability of our 3D software engine is the capability of speaking. Currently, the 3D NFTs can speak in one of three different voices. The 3D NFTs can speak either in a male voice, or in a female voice, or in a whisper kind of a voice. In addition to the three basic voices, there are three different flavors of voices. A voice can be spoken either in a normal speed manner, or in a fast speed manner, or in a slow speed manner. And if we take a male voice and it is spoken in a slow speed manner, then this voice can come as the voice of a masculine person or the voice of an old person. And if on the other hand we take a female voice and it is spoken in a fast speed manner, then this voice can come as the voice of a funny person or the voice of a little girl. The second additional and important capability for our 3D NFTs is the capability of voice recognition. Our 3D NFTs can recognize voice commands, and if, for example, we have a 3D NFT which is animated by moving in a random fashion around a window, then we can issue our very first voice commands to the 3D NFT to stop moving. And then the 3D NFT is going to stand still and stop moving. We can issue following voice commands to the 3D NFT to move left, move right, move up, move down, zoom in, zoom out, rotate. And then the 3D NFT is going to fulfill each one of these separate voice commands and move left, then move right, move up, then move down, come closer, zoom in, go farther away, zoom out, and start rotating. The next additional and important capability for our 3D NFTs is the capability of them having a basic artificial intelligence. You can ask the 3D NFT to describe something. For example, describe Web3 or describe decentralization or describe Russia. And then the 3D NFT is going to describe in few sentences about Web3 or about decentralization or about the country called Russia. You can ask the 3D NFT what is your name, and then the 3D NFT is going to reply with their name. You can ask the 3D NFT to, for example, who are you, and then the 3D NFT is going to reply with who they are. The last but not least important capability of our 3D NFTs is the capability of them being displayed in a way of stereoscopics. What stereoscopics means is that part of the 3D NFT is going to be displayed in red or reddish colors, and another part of the 3D NFT is going to be displayed in blue or bluish colors. Then you can come to our 3D NFT marketplace, and probably now is the time to tell you the name and the URL of our 3D NFT marketplace. It is 3dnft.decentralizedweb.org. 3D NFTs typed in a way of the number 3 followed by the letter D followed by 3 other letters NFT, and it is all together 3D NFT. Then there is dot, and then there are two words which are typed all together: decentralized and web. Their type decentralized web, then there is dot, and it ends with org. Once again, 3dnft dot decentralizedweb.org. On the top of the first and every other screen, there are a number of links, and one of these links is links to accessories. When you click on this link, you're going to see that we're offering special glasses, and when you order one pair of these glasses, you're going to see that one lens of these glasses is red and the other lens of these glasses is blue. You can click on the button to order, and you can complete this transaction, and when you receive these glasses, you can put these glasses on, you can request a displaying of the 3D NFTs in a way of stereoscopics, and you're going to see the 3D NFT as coming out of the flat two-dimensional computer screen, and you're going to see it in real 3 dimensions. With this said, I'm ending talking about our 3D NFT collection and our 3D software engine, but I like to tell you a little bit about our 3D NFT marketplace. In our 3D NFT marketplace, we have our own blockchain instance. This blockchain instance runs Ethereum software, and this is the same software which runs on Ethereum mainnet. It runs on Binance Smart Chain. It runs on Polygon Matic chain. It runs on Avalanche Avax chain, and it runs on many other famous and not so famous blockchains. By having our own blockchain instance, then we do not charge gas fees for the deployments of the smart contracts for the non-fungible tokens, and we do not charge gas fees for transactions of transfer of ownership from one user to another user. By having our own blockchain instance, then we detach the payment for the purchase and then receiving proceedings from sale from a single popular blockchain, and we allow our users to buy and receive proceedings from sale of our 3D NFTs in multiple crypto coins. Currently, the choices of crypto coins include 4 different crypto coins. It includes Solana Sol, Polygon Matic, Avalanche Avax, and Qcoin, which is a big centralized crypto exchange. It has a coin called KCS. In addition to buying and selling of our 3D NFTs in crypto, we have a second parallel and independent way of buying and selling 3D NFT, and it is done entirely in fiat currency. I can give an example of this process, like for example, if you are a user and you come to our 3D NFT marketplace, you click on the composite image of our first collection of 3D NFTs, then you're going to see all of the 3D NFTs in our first collection listed. You're browsing through the number of these 3D NFTs which are displayed. Then you see one 3D NFT that you like. You click on this 3D NFT. Then what you're going to see is a short video showing this 3D NFT as it is moving, and then you're going to see a drop-down menu which has 4 different choices of paying with crypto coins, and the 5th choice of paying with fiat currency. Let's say you click on this, click to select this 5th choice, then you click on the button to advance next, and then you're presented with a screen where you can put the number of your debit or credit card, expiration date, CVC, and when you click on the button to make the payment, what is going to happen is there is going to be transaction and conversion from your national fiat currency to US dollars, and it is going to be deposited in our bank account. With this set, Then we're going to follow this action with the second action and the transaction and the transfer of the initial ownership of this 3D NFT from the marketplace to you, and now you become the first official owner of this 3D NFT. So let's say you play for a while with this 3D NFT, and at some point you decide to put this 3D NFT for sale. You can decide on the price you put for sale of this 3D NFT, and let's say there's a second user which comes to our 3D NFT marketplace. In the same way, they browse through the collection of 3D NFTs, and let's say they like in particular the 3D NFT that you put currently for sale. The second user then goes through the same steps of between selecting crypto coins and selecting a payment with fiat currency. So let's say they select the payment with fiat currency, they click on the button to advance next, they put their number of debit or credit card, expiration date, CVC, click on the button to advance next, and then what is going to happen is there's going to be a conversion and transfer and conversion from the national fiat currency of the second user, which could be different than your national fiat currency and different than US dollars, and this transaction is going to be deposited in our bank account in US dollars. We're going to follow this action with a second action and transfer the ownership from you, the first user, to the second user, and now the second user becomes a current owner of this 3D NFT. Then we're going to follow this second action with a third action and transfer from our bank account from US dollars, conversion to your national fiat currency, and this deposit is going to be placed in your bank account in your national currency, and this is going to be the payment for the sale of the 3D NFT. And with this set, I'm ending talking about this first project that we're working on. The second project that I like to mention is the project of related with electric vehicles, charging of these electric vehicles, and like having control over the switching of power on and off provided to electric vehicles or other consuming device or vehicle or tool. And with like year by year, we are going to be expecting, and we're projecting exponential growth of electric vehicles, which are going to be replacing internal combustion engines. The current way of charging of these electric vehicles is done in what I call it gas station model, like resembling the way internal combustion engines come to places called gas stations. They stop, they connect the hose to their vehicle, to the gas tank of their vehicle, they fuel their vehicle, they pay for the gas they load it, and then they leave. In the same way, electric vehicles, they come to special locations where there are several columns, and each of these columns have uh, electric cable, and when like the owner of an electric vehicle comes to a location like this, they stop specific um, station. They connect the electric cable to their electric vehicle. They start charging their electric vehicle. Then they pay for the like electric vehicle electric energy. They load it in their electric vehicle, and then they are leaving this location called resembling electric vehicle charging station. We project and we estimate that the number of these electric vehicle charging locations is going to become insufficient to handle the number of electric vehicles which come to charge their vehicles. So what we're proposing is installing electric vehicle chargers, and we're working on projects which are specifically tailored for this case, and the location of charging of these electric vehicles could be the location of the home if the owner of this electric vehicle is living in an apartment building, and this apartment building has a ground floor or underground floor with parking lots, and we propose installing of the kind of products that we are currently developing, and we will be offering at this ground or underground parking lot locations. And with this with this location at the home of user, of the owner of this electric vehicle, we can also propose installing electric vehicle chargers at the place of work of this electric vehicle owner. If they work in an office, high-rise office building, and this office building has ground floor parking lot or underground floor parking lots where the office workers in this building are parking their vehicles during the day while they're working at this specific location. But like our product, which is going to provide the basic functionality for charging electric vehicle, it is also going to provide number of additional capabilities. The first additional capability is the capability of identifying the owner of this electric vehicle, and our products are going to be outfitted with near-field communication reader, and this reader could read either the debit card or credit card, or like a near-field communication card token, which could be a key mounted in a keychain, or it can read a ring which could be placed in the finger of this owner of the electric vehicle. And then this specific product that we have can identify the user. It can then switch on the electric vehicle, and the user can connect the cable of this charging vehicle charging product to their vehicle, and then they can start charging. We can also provide the capability of billing these users by providing the charge, like providing the service of charging the debit or credit card of this user for the electric energy that they consume, either at the place of work or at the place of living, at their home. And in addition to this capability, this product is going to have the additional capability of being remotely controlled. This is a very, very important capability, because with the electric utility providers, they have to at every moment balance the number of electric vehicle which is generated with the number of the amount of energy consumed by consuming entities. If there is some disbalance between the amount generated and the amount consumed, then the electric utility cannot provide sufficient energy, and they have to turn off specific locations, specific neighborhoods, or specific city, so that they can bring on sufficient electric generating power, and then they will be able to turn on this specific location, neighborhood, or city that was blacked out for a specific amount of time. To avoid this scenario where multiple, for example, electric vehicles, they come to they request to start charging at a specific moment, like for example midnight, which will be having lower charge for electric power consumed. To avoid this scenario, we have remote controlling capability, and these charging stations, they can request the specific, they can provide to the electric utility, or we can aggregate this demand for power, and we can provide this aggregated demand to the electric vehicle moment by moment. So, and then the electric utility provider can can bring additional generating capability, and when the electric power, the charging station, is turned on for multiple vehicles, these charging stations are going to be provided with sufficient energy by the electric utility, because it got notified in advance of this upcoming demand for energy. With this said, I'm going to tell you the name and the URL of this second project that we're working on. It is power.rstack.com. Power is the ordinary word for power, then there is dot, then I can spell letter by letter what follows next. It's Alpha, Romeo, Sierra, Tom, Echo, Charlie, Hotel. Altogether, it sounds like RStack. Then there's dot, and it ends with com. Once again, power.rstack.com. We can see that we did release number of articles. One of these articles is an article which is talking about comparing this gas station model versus parking lot model. In addition to this, there are three different surveys: survey on the hardware, survey on the software, and survey on the feature of products, and you can fill and submit these surveys, which is going to tell us are you utility, or are you an end user, which kind of electric energy would you like to use, and how much power do you want to put into your vehicle, and how long do you want to charge, and so on and so on. With this said, I'm ending talking about this second project, and I like to mention a third project that we're working on. The project is called Elements of Artificial General Intelligence, and it is working on putting together multiple different technologies which are going to be then tailored and employed in an intelligent device, which could most often be a robotic device. The number of these technologies include voice synthesis, voice recognition. It includes command recognition, image detection, image classification, and general vision capabilities. It includes displaying of the information and control of user to multiple of these intelligent devices. We do not have yet a website and a project URL for this third different project, but we are going to put these accumulated elements in a GitHub project. We're going to put also a website, and in the following presentations we're going to mention the progress on this third project that I will be mentioning. And with this said, I'm ending this educational presentation. Stay tuned for part 2 of today's presentation. Thank you for listening, thank you for viewing, and goodbye.